So guys, welcome to my channel Arduino Science Fun. You can find me on Twitter at FunArduino. So let's start immediately to talk about my next project in which I will use Arduinos for science and fun, which is actually sending a balloon. This is a balloon to space. And this will be a balloon filled with helium gas, okay? And since helium is less dense than air, this balloon can generate a lift. And we can connect to this balloon a so-called payload, which is basically a box in which you put some interesting stuff inside. We will see later on. And if the weight of this payload is lower than the force of the lift that this helium balloon can generate, all the system will start rising up. And this system can usually reach altitude of around 30 to 40 kilometers height. And I'm sorry a bit for the microphone, which is a bit of shit, but I hope for next video I can get a real microphone so you can hear me better. Anyway, what happens here after 30 to 40 kilometers in altitude? So we know that when we increase the altitude, so if we increase the altitude, the pressure of the air will decrease, meaning that there is less force pushing on the outside part of the balloon, and as a result, the balloon will start with a certain volume at ground, and these will increase more and more and more and more going up. And actually, what happens is that the balloon at a certain point will explode. And what happens there? So in that moment, the helium balloon is exploded, then there's no more lift, and the payload will simply start to fall down. Then, at this point, there will be a free fall of the payload. So this is not very good because at a certain point the payload will reach the ground and smash into the ground and be completely destroyed. And this is not what we want to do. So we need to make a little modification here and actually remove this direct connection to the balloon so that we can basically have the helium balloon here and the parachute in the middle. The parachute can slow down the free fall of the payload. Now, let's come to the point of what's inside the payload. What do we want to put there? What do we want to bring to space? What's actually inside our payload? Here. This is just a box, probably a styrofoam box, because it's light enough, but also enough insulating to protect what is inside from the outside very cold environment. What we can put here is basically we can start with some cameras. Okay, some nice GoPro camera or action camera, whatever, on the bottom part and on the top part, on the side part, let's say, so that we can take some nice good video of this travel of the balloon. But of course we need some power, so we need to power up this system, and we will see that this can be a kind of concern because at the higher altitude the temperature is very low, and batteries start not working good, or the capacity of the battery is really decreased with low temperature. So we need some kind of additional battery, kind of power bank, to power up all our system, which, as I told you, will consist about 2 cameras here. And I want to collect some nice data. In order to do this, I would like to install the brain here of our payload, which is an Arduino board. And an Arduino board which can basically record several data in an SD card. Among several data there is of course GPS positions, because we want to follow our payload, our system, where it goes, where it travels. And to this Arduino we want to connect several sensors, right? It's Arduino science and fun. So we want to have fun, but we want to make some science. So which kind of sensors and what can we measure up there? So up there is, even if not so much, air. And of this air, of this atmosphere, we want to measure the temperature on some basic stuff like humidity and, of course, the pressure. In what we call air, there is, of course, gases. Which kind of gases can be interesting to measure up there? So we reach the altitude, we say, of 30 to 40 kilometers, which is the stratosphere. And in the stratosphere, there is this nice layer of beneficial gas for us when it is up there, which is the ozone, because it stops the bad UV radiations from the sun. But we can measure other stuff like CO2 and like methane. Okay, all this can be done with some Arduino sensors. We will have a look at this in details later on. Plus, I would like to measure also some light. So, for example, the UV light, which is directly connected with its own ozone story. And might be, if I manage to find a way to get some micro or very small spectrometer to make some other interesting analysis, I will say that. Anyway, this is the basis of the sensor system, and in future videos I want to go into detail of all these sensors and components like GPS system, the SD card, and try to have a look how to implement everything, and also need to take into account all what is concerned power supply. So how much power do we need, how much current do we need, and is this feasible to do with all the stuff at that temperature? If you want to know the answer and if you are interested, you can start following me on Twitter, subscribe to the channel, and yeah, let's see you to the next videos.